This is Vinay here. Today we are going to see a linear search, one of the topic from the data structure. In this, we are going to in this video I'm going to demonstrate you, linear search with a simple example and how it works. We will be discussing in this video. So, for example, if you have a n number of items in your uh, list, and if you want to understand any number specific position of that item, so for that purpose you can use that linear search algorithm. And how linear search works: so suppose if there is item stored in list, and if you want to find out any of the item, your linear search algorithm what do is actually read that value and try to visiting each element of the list until and unless it find the exact value. Once it find the exact value, it return the position of that value, and your linear search algorithm terminates there. That's the only linear algorithm do. The linear algorithm is also known as sequential algorithm because it works in sequence. Okay, so that's all about theoretical explanation of linear search from my side. Let's begin with the practical. So here we will try to take some item in list. For example, I have one variable, let's take it as a x only, so x, and assign some value in its list. For example, let's begin with the number. So suppose we have a number 4, and so no, it's not a string, so we can direct type 5 6 7 1, then 90, then 2. This is our list. And now the next what I want to do is, uh, let's make the linear search algorithm function where we can implement that linear search algorithm. So we have to create one function. uh, like we can go for defining the function first. So define, here we will call this function as l underscore s, standing for linear search. And then we have two parameters. First parameter will be the list. So that list will, we can call that list as a linear search. So uh, sorry, that list will be called as item list. So suppose I'm storing multiple item, that's why I'm calling it as a item list. And the item which we want to find out, so I can say that it's a search. The item which you want to search is search item. Okay, so two variables, two parameter we are going to pass to this function. And then as in Python we write with the colon. And then we need one more thing, uh, to locate the index. So we can take index number where it's begin with 0, because in array we all know that positions with it's count from 0. So we will initialize it to 0, index number which is at 0. Now we want to initialize one more variable which says that either this number exists or not, it's there or not. Okay, so I take one variable called it exist, and I will assign it value in boolean. So suppose initially that number does not exist, so false. Exist is equal to false, I have assigned false. And now here we can write different type of loops, but let's begin with the while loop, where we can write while index underscore number is less than length of the, so in Python we write len for finding length, and then item what list, because we are going to compare it with the length of the item. Okay, and now and not exist. Okay, not exist. This is my condition. What condition says? While index number is less than length of item list and it does not exist. Means what? Initially we have exist as a false, so if it comes here it will become true. Agree? So while the index number is less than the length of list and exist means it's true, then what to do? Then we have to perform if item underscore list. Now item list what? So we have to find out the index number. Okay, so if item list number which is having index, we can take refer that with the index number, is equal to search item, because it is going to visit each of the item in the list. So if that matches in search item, it matches with the search item. Okay, so what? Then it exists, right? If it matches the index number of the item list is equal to search item, then we can say this exists in the list. So exist, because we have taken as a variable here, it will become true. Understood? I hope everyone is understanding. So exist is equal to true. Else, so we have to take one back, else the index number, else index number will increase. So index number is equal to index number plus 1. Clear? Means it will go to 0 first, then if it is not found, then it will again increment by 1, then it will again try to find it out. Okay, so by this way it will iterate until unless the while condition meets, does not meet. Okay, yeah. So now we have to return the both the value. Okay, so return, what to return? Does it exist? So yes, I want exist and I want index number of that item. Okay, so we have done with the function. Now we have a x as a list parameter here, list, and we are passing these values, and with the linear search algorithm which we have implemented in the form of function, we are going to test it now. So as we all know, we need two parameters here to run this function. One is item list and the second is search item. So let's print here, print my function name is linear search ls, and then the first item list, because we have item in this list, so that is x, comma, we want to find out. So what do you want to find out? So suppose you want to find out 90, so we'll take y as a parameter and 90. Okay, so we can pass here, that is search item, which is here 90, we want to find out 90, so we'll pass here 90 y, or you can directly write 90 here. Instead of writing y is equal to 90, we can write 90 directly also. Okay, so let's begin this, run this program and see the output. Okay, so there is one error. Let me see what is that. Invalid syntax. So if I see here the item search, okay, search underscore item, if there is any problem in variable, item underscore list index number is equal to search item, it's all seems to be fine, equal to search item. Yeah, so sorry, I missed this because we are not assigning, we are comparing. So I missed this double equal to. um, so yeah, if the item list index number, we suppose is 0, so 0 item position is equal to search item, then we can say exist, or else we can say increase the number and search it again. Okay, so by this way I try to find out y is equal to 90, and that 90 is on which position. So let me print this value. It says fifth, and does it exist? The question is exist, so yes, it is true. And the fifth is here value of position, because it counts with the 0 0 1 2 3 4 5. It's a fifth position. So by this way we can find the position of any items. Okay, so this was about a numeric value. The major role of linear search comes where there is, you know, anything which is unsorted. Again, here we were having unsorted values, but again we, you can say, we can sort it out and we can find it easily. But what if there is any number plus any symbol plus any alphabets? So in that sense also, the linear search work in a similar way only, means by visiting each number one by one, each item one by one, and matching exact, and then throwing out the position of that specific item from the list. So just I want to demonstrate you that how it work with the alphabets and the symbols. So for example, suppose here we have this number 4, let it be here is a 4, and then here we have a, and then suppose here we have some symbol dollar, we can take dollar. Okay, now because we cannot sort it out, so let's see, um, let's try to find out the position of alphabet a, small a. Okay, so the function exists same, because the linear search algorithm, as per the algorithm, this program works fine. So there is no change in program, just change in list and the search item. So search item, I just want to find out dollar. So let's see if it works with the alphabet, symbol and number. So that a list is created. Now I want to create, I want to run this function with input y is equal to dollar. Okay, now we have x and y both, and I'm just calling that function. See, it's returning exist, yes, true, and index number of that y value, which is dollar. So it's returning 3. Let's see if it is 3. 0 is fourth, 1 is a, 2 is 6, and 3 is dollar. Of course that's true, means our program is working fine. And this is how the linear search, which is also known as sequential search, works. Okay, I hope this is helpful. Let's name that program simple linear search algorithm. Rename. So by uh, this way we can demonstrate simple linear search algorithm. Thanks for watching video.